Welcome to the video lecture for section 2.1. This is for MAC 1105. My name is Hartigari Young. In this section, we're going to be talking about the distance formula and the midpoint formula. And so here's an XY plane. We've seen this before. XY plane has four quadrants, starting in quadrant 1, quadrant 2, 3, and 4. Here we have some plotted points. 3, 2. We always go, it's always XY. So we always, if you have a point 3, 2 is an ordered pair, it designates 1 point. And so you go 3 units to the right on the X and then 2 units up on the Y. And then for the point -2, -3, what we're going to do is we're going to go over -2 and then down -3. And then for the point -3, 1, we'll go over -3 or 3 units to the left and then 1 unit up. And so again, here are the quadrants. Quadrant 1, they're both positive. In quadrant 2, the X is negative and the Y is positive. In quadrant 3, they're both negative. And in quadrant 4, the X is positive and the Y is negative. And so using the distance formula to find the distance between 2 points, so for example, if we have the point 1, 3, and 5, 6, we can use the distance formula to find the distance between those 2 points. And if you notice here, the distance formula, basically what it does, it creates a right triangle and then uses the a squared plus b squared is equal to c squared formula to find the distance or the length of the line segment that connects the point 1, 3, and 5, 6. And the distance formula is simply the square root of x2 minus x1 squared plus y2 minus y1 squared, where p1 is the point x1, y1, p2 is the point x2, y2, and then the distance between those 2 points is the formula given in number 1. And so the proof of the distance formula, like I said before, is literally just the a squared plus b squared is equal to c squared formula. And so here's an example of the distance formula. We have a point -4, 5, and then 3, 2. So you can designate one of the points x1, y1, and the other one x2, y2. You go ahead and put these values into the distance formula. And so the 2 points were -4, 5, and then 3, 2. So we did 3 minus -4 squared plus 2 minus 5 squared, which then gives us 7 squared plus -3 squared, which ends up being the square root of 58 and is approximately 7.62 units. Now, the next example is using algebra to solve some geometry problems. So we're going to consider the 3 points, A, B, and C. So A is -2, 1, B is 2, 3, and C is 3, 1. We're going to plot each point. We're going to form the triangle ABC. We're going to find the length of each side of the triangle. We're going to show that the triangle is in fact a right triangle, and then we're going to go ahead and find the area of the triangle. And so figure A shows the points A, B, and C forming triangle ABC. And then we find the length of each side. We use the distance formula. So first we find the distance of AB and then BC and AC. So here we see that we got 2 square roots of 5 for the distance between A and B. We have the square root of 5 for the distance between B and C. And then we have 5 for the distance between A and C. So if the sum of the squares of the length of the 2 sides equal the square of the length of the third side, then the triangle is a right triangle. And again, this is the a squared plus b squared equals c squared formula. So then we find here that when we do the distance of ab squared plus the distance of bc squared, that's going to be equal to the distance of ac squared. And so you can see that we get 20 plus 5, which is equal to 25, which is then equal to the distance of ac squared. And so because the right triangle is at vertex B, the sides A, B, and BC form the base and the height of the triangle. And then its area becomes the formula is 1/2 times the base times the height, which is 1/2 times 2 square roots of 5 times square root of 5, which is 5 square units. The next thing we're going to use is the midpoint formula. And so the midpoint formula, simply what it does, it just finds the distance, the equal distance of a midpoint or a point between the 2 endpoints. So M would be the midpoint of the line segment that connects point 1 and point 2. And so the midpoint formula, the form is simply x1 plus x2 divided by 2 plus y1 plus y2 divided by 2. And so here we have an example. We have P1 is -5, 5, P2 is 3, 1. We're going to go ahead and plot the points and end the midpoint. And so x becomes negative 5 plus 3 divided by 2, which is negative 1. Y is 5 plus 1 divided by 2, which is 3. So here's point 1, point 2, and here's the midpoint. And that's the end of section 2.1. Thank you.